Hello, Math 1020 class. Let's do the next chapter review for the final. This is chapter 3. Write the equation of the quadratic function whose graph is shown to the right. So let me give you the sketch that I've been given. And some of these points are labeled. This one is 0, 0. This one is 6, 0. And it looks like the vertex there is 3, negative 18. So we're supposed to choose the correct equation for this particular graph. It is multiple choice, but I just want to say that HK, those are the letters that usually are used to represent the vertex. And one of the forms of the equation of a quadratic function is this: a times x minus h squared plus k, where hk is the vertex. So just by virtue of the fact that we know what h and k are, I know the equation looks like this: some constant a times x minus 3 squared minus 18. So I just replace the h with a 3 and the k with a negative 18. So just that might allow you to come up with the correct answer, since it's multiple choice. But there is a way to find this a too, which is just to use one of these other points that the curve goes through, say 0, 0. Since the curve goes through 0, 0, when I replace the y with a 0 and I replace the x with a 0, I should get a true statement in the original equation. So notice that's going to allow me to solve for the a. If I add 18 to both sides, it looks like a is 2. So the equation is 2 times x minus 3 squared minus 18 equals y. All right, let's consider the graph of this function. Notice, by the way, that is a quadratic function in factored form, or vertex form. Part A says, give the coordinates of the vertex. Well, remember the trick: change the sign of the first number and leave the second number alone. So that negative 3 gets changed to a plus 3, and we leave the 4 alone. So it's real easy to find the vertex of a quadratic function if it's given to you in factored form. And we did that trick in class. And now we just have to choose the correct graph. And this one is multiple choice. You can just plug this into a calculator, I guess. But I can also sketch it really quickly. 3, 4 is about right there. And notice, by the way, the coefficient a is positive. That means this thing opens up. So you just have to kind of look for the graph that looks like this. Well, there's only one that's even close. But let's move on to number 3. Solve the equation for t. 3t squared plus 23t plus 40 equals 0. And notice, by the way, it doesn't tell us which method to use. It doesn't say we are supposed to do it by factoring or quadratic formula. So usually, if you're not sure, try to solve it by factoring first. And if that doesn't work, use the quadratic formula. So the first thing to do is come up with two expressions that will multiply to give you 3t squared. Now come up with two numbers that will multiply to give you 40. We could try 8 and 5. If we do 8 and 5, notice the outer is 15t. The inner is 8t. I think I got lucky on the first try, because if I add 15t to 8t, I do get 23t. So those both should be positive. By the way you check this is to FOIL it. So if I FOIL it, the first is 3t squared, the outer is plus 15t, the inner is plus 8t, and the last is plus 40. So that is the same thing as this when you combine terms. So the next thing to do is set each factor to 0 and solve for t. So it looks like negative 5 and negative 8/3. Now this one says use the quadratic formula to solve. Now you have to know the quadratic formula for the test. You have to have it memorized. But when you use the quadratic formula, make sure all your terms are on the left-hand side and you just have a 0 on the right-hand side. But what I would do is write down the formula. So this is something you have to have memorized. And just remember, the a is the one in front of x squared, the b is the one in front of x, and c is the constant. So negative b in this case is negative 3. B squared would be 9. A is 1, because that's the one in front of x squared. There's an understood 1 there. And it looks like c is negative 1. So notice I'm counting the negative sign as part of the number. All over 2a. So we just have to simplify this. Well, this actually turns into 9 plus 4, which is 13. So that's pretty much it. This is an acceptable form for the answer. And in fact, when I click on the x equals button, it gives me the plus or minus symbol. So you should be able to input it exactly like that. The profit for a product is given by the following function. Where X is the number of units produced and sold. How many units give break-even points for this product? Okay, so when do we break even? We break even when the profit is 0. So you just have to set this profit function equal to 0 and solve for x. And this one looks like kind of a messy equation. Easier said than done, solving this thing for x. But you know, the numbers are so big and messy, it might be easier just to use the quadratic formula on this thing. So I mean, I could divide both sides by negative 15, but I think it might be faster to just plug the numbers into the quadratic formula. So that's what I'm going to do. And I really think the toughest part is the part under the square root. All right, so let's use the plus first. That's really two different numbers. Negative 1650 plus 750, which is negative 900 all over negative 30. And the other one, we choose the negative. So negative 1650 minus 750. Okay, so it looks like 30 and 80. Find the equation of the quadratic function whose graph is a parabola containing the following points. So this looks like a regression equation to me, or a regression problem. So I might do this one on another video. I'll skip it for now. And I believe number 7 is also a calculator problem, but I just want to mention something about it. I will probably just do number 6 on the other video. The tricky part about number 7 is to actually come up with the points. Let me read it to you. It says a ball is thrown upward from the top of a 160-foot high building. So the height of the building is 160 feet. The ball is 192 feet above ground level after 1 second. So first of all, let me make the observation that when t is equal to 0, the ball is 160 feet above the ground. And it says the ball is 192 feet above the ground after 1 second. So that gives me another ordered pair. So notice I'm making the first coordinate the time and the second coordinate the height above the ground. And then it says it reaches ground level in 5 seconds. That means after 5 seconds it is 0 feet above the ground. So really, you just have to translate the words into 3 points in this problem and then use the same regression trick that you used in number 6. So that's why I'm probably just going to do number 6 on the other video. But that should do it for chapter 3. So I will probably do 2 additional videos for these calculator problems, one for the Inspire and one for the TI-84. Well, let's go ahead and do some problems from Chapter 4. So actually, I think I'm going to have 4 videos. 1 video for Chapter 1, Chapter 2, 1 video for Chapter 3, 4, 1 for 5, 6, and then a couple of calculator videos. I guess that's a lot of videos. How is this graph transformed from the graph of y equals x squared? So here is the function we're given. And it says, how did we transform x squared to turn it into this? So you just have to use those transformation rules. It looks like we've replaced x with x minus 2, and then we added 1 to the function. So remember, whenever you replace x with x minus 2, that means you move it to the right 2. And then whenever you add 1 to the function, that means you move it up 1. So we took the original function of y equals x squared, we moved it to the right 2, and then up 1. And that is multiple choice. Determine algebraically whether the graph of the following equation is symmetric with respect to the x-axis, the y-axis, or the origin. Okay, so let's take a look at this thing. Y equals 3x squared minus 4. So let's start by doing the test for symmetry with respect to the x-axis. And remember, the trick is to replace y with negative y. And see if you can manipulate the equation and make it look like the original equation. And I don't think I can in this case. I mean, I could multiply both sides by negative 1, but that would change the right-hand side, and I couldn't ever fix it. So this is not symmetric to the x-axis. Let's try the y-axis. Well, remember, the trick is to replace x with negative x, and in this case, if I do that, I get this. But it looks like if I simplify a little bit, I do, in fact, get the original equation. So this one is symmetric to the y-axis. What about the origin? Well, you're supposed to replace both x and y with their negatives. If I do that, I get this. And I can simplify the negative on the right-hand side there a little bit because it's being squared, but there's nothing I can do to get rid of the negative sign in front of the y. So this one does not pass the test for symmetry with respect to the origin. This one is only symmetric to the y-axis. And you know, you didn't necessarily need to do all that work. Usually you just have to focus on the variable that's being squared. So this kind of implies that I can replace x with negative x. That means it's symmetric to the y-axis. That's kind of the shortcut. If both variables are squared, you can conclude that it's symmetric to the origin. Actually, all three. But let's do number 3. And this one is the same problem. What kind of symmetry does this have? So we could do it step by step. I guess we'll do it that way. Let's test for symmetry with respect to the x-axis first. I don't think it's going to pass the test because there's no way for me to get rid of that negative sign without changing the equation. Is it symmetric to the y-axis? Well, we'll replace x with negative x. If I do that, I get y equals 12 over negative x. Same issue. I can't get rid of that negative sign. Now, what about the origin? I think this one will be symmetric to the origin, because if I replace both variables with their negatives, I get this. But notice that means if I multiply both sides by -1, it does turn into the original equation. So this one is symmetric to the origin only. All right, let's do this one. F of x is equal to 7x minus 6. G of x is equal to 1 plus x. And this is the one where we're supposed to find the sum, difference, product, and quotient. So let's start off with f plus g of x. That's just the sum of the two functions. F minus g of x, that's just the difference. And notice, by the way, I'm putting g in parentheses because I have to distribute that negative sign. So again, going kind of fast, but these videos are already so long, and you can always pause and rewind. Next one is f times g of x. That's just the product of the two. So in this case, you probably want to FOIL this thing. First would be 7x, outer 7x squared, inner minus 6, and last minus 6x. So combine terms, and I think you get this. And d is f over g of x, which is defined to be f of x divided by g of x. And I can't really do anything to simplify that one. That's the answer. And the last part says, what is the domain of the function in g? And I'm talking about this guy. Well, remember, you cannot divide by 0, so 1 plus x can't be 0, which means x can't be -1 if you subtract 1 from both sides. But they want this thing in interval notation, so everything except -1, what does that mean? Well, it's everything to the left of -1 and everything to the right of -1. So it'd be negative infinity to -1. Notice the parenthesis next to the -1, union -1 to plus infinity. And they want that thing in interval notation. You have to type it in yourself. That's not multiple choice. Let's do number 5. F of x is equal to 9x minus 1. G of x is equal to 10 minus 2x. So we're supposed to find f of g of x first. And by definition, that's function f evaluated at g of x. But remember, you always do the one on the right first. So replace the g with 10 minus 2x. And then you want to find f of that. So you basically pick this thing up and put it right there. Now let's do g of f of x. So again, always do the one on the right first. In this case, it's 9x minus 1, which is the f. Now pick that thing up and put it in where the g is, in the g function, I mean. So 10 minus 2x is g, but instead of putting an x, I'm going to put that 9x minus 1. This time f of x is 2x squared, and g of x is x minus 6 over 2. So part A says, what is f of g of 4? So that's just f of g of 4 written like this without the open circle. But once again, always do the part on the right first. So what is g of 4? Just put a 4 right there. And now I need f of negative 1. So put a negative 1 right there where the x is. And I just get a 2. And in part B, it says g of f of negative 5. Well, that's this. So what is f of negative 5? Let's see. Just put a negative 5 right there. 2 times negative 5 squared. And that's 2 times 25, which is 50. So I'm really looking for g of 50, which means I need to put a 50 right there. So it's 50 minus 6 all over 2. And that's 44 over 2, which is 22. Again, going real fast, but use that pause button and the rewind button. Let's try number 7. A manufacturer of a particular item has monthly fixed costs of $500 and variable costs of $15 per item. So the fixed costs are $500. And the variable costs are $15 per item. And it sells the items for $25 a piece. Write a function that models the profit P from the production and sale of X units as part A. Well, we really need the revenue function and the cost function before we can find the profit. And the revenue is just the price per item times the number that you sell, which is X. And I think we're supposed to assume the cost function is linear in this case. And it's always the variable cost times X plus the fixed cost. And remember, by definition, profit is revenue minus cost. Be 25x minus, the cost function is 15x plus 500. Notice I put the cost function in parentheses. So it looks like that's the profit function. 10x minus 500. And now part B says the profit of 180 items produced and sold in 1 month is what? So that's really just P of 180. The rate at which profit grows is what? So we're looking for the rate of growth of the profit function. But notice the profit function is linear. And you might recall that the rate of change of any linear function is just the slope, which is the coefficient of x, if it's in mx plus b form. That just means if we produce and sell one additional item, we increase our profit by $10. Let's do number 8. For the function defined by f of x equals 5x minus 5, complete the table below. And we're given 2 tables. And this is the one where you just have to remember that for a function and its inverse, you switch around the coordinates. Okay, so so the x-coordinates of the inverse function become the y-coordinates of the original function. So all I have to do is take these guys and put them right there. That's pretty much it. You really don't even have to plug anything into a calculator. And then if I want these guys, I just have to move these over here. Okay, let's do number 9. Find the inverse of g of x equals 7x plus 5. So here are the steps. Remember, the first thing to do is replace function notation with a y. And then the key step is to switch around the variables. So wherever you see an x, put a y. Wherever you see a y, put an x. And then solve for the new y. So I guess I would subtract 5 from both sides next. And the very last thing to do is get y by itself by dividing by 7. And that should be the inverse of g. And it looks like that's the last problem from chapter 4. So that should do it for this video.